Since we've already started looking at IP version 6 addresses, we're going to stay there because we've summarized them so far, but of course we haven't gotten into details about how the address is built, where it's coming from, what the different parts are, etc. And I want to do that now. So I'm saving some of the more nuts and bolts stuff about version 6 for the end of this particular section. And by that I mean like frame formatting, maybe a little bit of a history lesson, just a small one, I promise. But we're going to hit that at the end. So we're going to do something a little different here and keep working with our version 6 addresses. And the version 6 addresses have huge advantages over version 4 addresses that you aren't quite aware of yet, but you will be. Because it's especially true when it comes to subnetting and summarization. Now, you've done some version 4 subnetting. You haven't done any summarization yet in this course. And just as another quick explanation of what that is, if we write out some of the routes in our routing tables in binary, we can see what bits they have in common, and we may be able to represent multiple routes with just one entry in the routing table, a summarized route, if you will. So we really like that because what do we always want to do with our routing tables? Keep them complete and concise. And the conciser we can keep them, the faster the overall routing goes. Now the reason I mentioned this here, and I believe in the previous video, is that version 4 really wasn't developed with subnetting and summarization in mind. You can do it. We've already done the subnetting. We'll do summarization later. But it's a little clunky, especially once you start working with version 6. You won't even know there's a problem with version 4 until you work with version 6 subnetting and you go, oh, that was easier. Because frankly, version 6 was created with especially summarization, but with subnetting and summarization in mind. And that's where our global unicast addresses begin to come in. Now, there's a bit of a food chain here when it comes to version 6 address blocks. And at the top of that food chain, so to speak, is the IP version 6 authority, the Internet Assigned Numbers Authority to be exact. And this is one authority we all have to respect. They're at the top of the version 6 address block food chain. And when an organization like your company or mine gets a block of addresses, well, it's already been subnetted a couple of times. Because first off, the block would have been subnetted by the IANA. They have the largest blocks of addresses, and they don't just hand them to you and me, you know, at Fred's Bank or something like that. What happens is the IANA has the largest blocks of addresses, the whole pie, if you will, and they assign subnets from those blocks to regional internet registries, RIRs, in accordance with very strict rules. Now, in turn, the registries assign subnets of those blocks to ISPs. Because again, the IANA does not assign subnets directly to ISPs. They don't give them directly to us. So then the ISPs get a slice of the pie. And then the ISPs subnet the address blocks they've been given, and those subnets come to the customers. So again, they start at the IANA, then those get passed down to RIRs. They're subnetted again. Those go to the ISPs, the IPs subnet them again, and finally, they go to you and me at Fred's Bank, the customers. Now, this is beyond the scope of the exam, but I like to give you extra information like this. I'd recommend a visit to www.iana.org/numbers for more information on this process. You have to click around a little bit, but it's beyond the scope of the exams, but it's interesting to see where the registries are, along with charts showing how the IANA keeps very detailed information on where these version 6 global addresses have been assigned. Because these are when I'm talking about the global addresses, those are really equivalent to the version 4 routable addresses. You know, these are going to be routable. Now it's our turn to start subnetting. We've requested a block of routable IP version 6 addresses from our ISP, a global routing prefix, if you will, and we've got them. You know, we've got the block. Well, now it's time to subnet the block again, and this time you and I are in charge of the subnetting. Now, the global routing prefix from our ISP comes with a prefix length, and in this example, we're going to use a /48. And the prefix length in IP version 6, it's really like the network mask in version 4. And the /48 prefix length is so common that prefixes with that length are often just referred to as 48s. You don't even hear people say /48. So if you hear that term, you know what they're talking about. We're going to do a walkthrough and then get on the live routers. We're going to assume a global routing prefix right now of 2001 1111 2222 /48. Now, with an IP version 6 address, it's 128 bits long. We got a prefix length set at 48. That would leave us 80 bits for subnetting. Not so fast, my friend. We also have an interface identifier in the mix. And knowing where this identifier comes from and how to create one and how to uncreate one and how to make one come on your interface automatically, those are valuable skills to have for the exam, and we're going to see all of those in action. This is almost always 64 bits long. I have to throw the almost in there, but generally it is 64 bits long. Now this ID is found at the end of an IP version 6 address, and it's really the host portion of the address. So you can see it's similar to version 4. You got your network portion of the address, then you got at the beginning, then you got your host portion of the address at the end, and what do you have in the middle? The subnetting information. And that's what we have here, because the interface identifier is 64 bits long. So if we have a 48-bit prefix at the beginning of the address and a 64-bit interface identifier at the end, that leaves us 16 precious bits for subnetting. And that's what we have right now. And we see the global routing prefix, the subnet ID is in the middle of this whole thing. It's a 16-bit value found immediately after that global routing prefix. And then finally, that interface ID. By the way, to calculate the number of valid subnets with IPv6, we use the same formula we used with IP version 4 subnets, and that is 2 to the 16th power, resulting in 65,536 subnets. That ought to keep us busy for a while. So a lot of subnets coming along with this prefix. Now, let's talk about determining the subnet IDs, because frankly, this is easy. It's really easy. Once you know where the GRP is, right there at the beginning, 48 bits, interface ID is 64 bits, your subnet ID is right in the middle. We know that the fourth block then from left to right is going to represent subnets. And you can just start writing them out, or on the job especially, you should enter them in a spreadsheet and go from there, because if the IANA is going to all this trouble of being super organized, by golly, we should do the same. You just go from there and you start with, well, what would you start with? The first 12 subnets would have a fourth block then of 0001, and then frankly just 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, and C. And what would the next two be? D and E, and then another one would be F. That's as far as you could go because we're doing hex. And I used this number of subnets in particular just to gently remind you of the hex values that we're using here. So the first four resulting subnet IDs are, and they're all going to begin with the same GRP, 2001 and then 1s and then 2s. And then the fourth block is our subnet number block, if you will. And we started there with 1, 2, 3, 4, and the double colon representing the right now everything else is a 0. Then you've got your /64 there now, because we're not using a /48 because this includes the 16-bit subnet field. So a couple of important points there, and that's what I just said actually. The 64-bit mask covers the 48-bit GRP and the 16-bit subnet field. And by the way, just as IP version 4 subnet numbers should not be assigned to hosts, neither should an IP version 6 subnet ID. The router will allow you to do so, but you're going to get a warning, and I'm going to show you that when we go live. I didn't want to just show you on the board. I'll show you live. But again, you know how you don't put the actual subnet number on a host with IP version 4? You don't do it with IP version 6 either, and you get a really odd message. But we will see that live, I promise you. Now, as you would expect by now, of course, any interface that's going to run IP version 6 has to have an IP version 6 address. Duh, right, I know. But we have an interesting choice here. Now, we could enter the full address manually using our 0 and leading 0 compression skills. That shouldn't be too much typing. Or we could just enter the subnet ID, which in this case is 0001 with a double colon to represent the subnet ID and a /64, and let the router come up with the internet ID part of the address. Well, that would depend which way we go here, would depend on whether you have a strict numbering situation with your host where your company says, okay, the naming convention is you start host with host 1 and then host 2 and host 3 and so forth, or you're just going to let the router come up with it. We're going to see both techniques in action. We're going to go with both of them. And what we'll do at the beginning of the next video is start the manual application of the address using the first subnet available and the first host address. And you see the address here on the screen. We will pick up right here when we come back.